Hello everybody. In this video we're going to be talking about calculating the equilibrium constant for certain reactions given information about the concentrations at the end of a reaction when it has reached equilibrium. So I want to break down what's on the paper so far. Instead of answering question 7, I have this, which is an abstraction of a chemical reaction. And how you would read this is just that in this reaction, we have A moles of substance A plus B moles of substance B yields C moles of substance C plus D moles of substance D. And like I said, this is just an abstraction to get you to understand this. K is the equilibrium constant, and it's calculated by putting the concentrations of all the products to the power of the coefficient in front of that number divided by the concentrations of all the products to the power of the coefficient in front of that substance. So I've gone ahead and I've labeled this reaction up here. 3 is going to be a lowercase letter along with 2 because it's a coefficient. And those are going to end up being exponents. In this problem, there is no little b because in front of n2 is nothing. And so you could write 1 if you want to, or you could leave it blank. When we get down to problem 8, we see that this is already plugged in for us. Hydrogen is a reactant. I labeled it A. It's going to go on the bottom where A is. Here you go. And the reason why it's to the third power is because in the balanced equation there's a 3 in front of hydrogen. Nitrogen is also a reactant in this equation, and so it's also going to go on the bottom, and it's going to be raised to the first power, or you can just leave the power out, because in front of nitrogen there is no exponent. Then NH3, ammonia, is a product, and products go on the top of this fraction. And it's going to be raised to the second power because in front of ammonia, there's a 2 in this balanced equation. When you go onto your calculator and try to solve this, there's going to be a lot of parentheses. The top should always be inside of its own. And the bottom should also be in a parentheses. And we get an answer, 148,148. And for K, we don't really need to worry about the units here. Right? It's really just a number. Now let's take a look at number 9, which is a little bit more complex, only because it uses scientific notation. So writing out the reaction or the fraction is probably not going to be too much of a struggle because it's going to be very, very similar to this one. The concentrations have changed though. So for hydrogen, we have 3 times 10 to the 4th, and it's still cubed because the reaction up here still has 3 in front of hydrogen. For nitrogen, 1 times 10 to the 4th, and we don't need to write anything here because raising something to the first doesn't change anything. On the top, still going to be squared because nitrogen still has a 2 in front of it. Plugging this into your calculator is going to look a little bit different because it has scientific notation. And if you didn't use parentheses here, and you just plug this into your calculator as 2 times 10 to the 4th squared, what you're really going to get is 2 times 10 to the 8th, which is not what we want. So we need to be sure that our calculator knows what we're talking about. So 2, remember this E, you get that by doing second and then the comma button, means times 10 to the 4th. And that whole thing is squared. Now when we're dividing, right, like I said at the beginning, the entire bottom should be in parentheses. So we're going to need 2 of them. The first one is going to encompass the entire bottom. The second one is there just for this. So we got 3 times 10 to the 4th, close it, and then we're going to cube that entire thing. Multiplied by 1 times 10 to the 4th, close both, and here we go. We get another answer. Again, this k doesn't have any units, and just for the sake of transparency, all these numbers are made up. Okay, I have no idea what the real equilibrium constant is for this reaction at standard temperature and pressure, but the point of today is really just to learn how to calculate it and how to plug it into your calculator. It's not about obtaining some deeper truth about chemistry. For this one, what we're going to do is the exact same thing. So we know how to plug this in now. Like this. And just like last time, we have scientific notation. So we're going to need a bunch of parentheses at the bottom. And the thing to notice is that this exponent is negative, which is fine, but your calculator has a few different minus sign looking buttons. This one is actually just for subtraction. It's not a negative sign, and it's not interchangeable. If you use this as a negative sign, your calculator will give you an error. This is the negative sign, and it must be used only as a negative sign. If you try to use it as subtraction, it won't work. So let's plug this one in now. Remember the top, we're going to put in parentheses, 3 times 10 to the negative 9, close it, and square it. Divided by 2 parentheses here. Remember, this one is for the entire bottom, and this is for that first term, the A term. 4.5 times 10 to the negative 9 cubed times 1.5 times 10 to the negative 9, close, close, answer. .58 times 10 to the 16. Now for these bottom questions, which of these reactions above most favors a forward reaction? Well, forward reactions are favored when K is large. And so we're looking for the largest K, which happened in number 10. So in this case, number 10, based on the information I was given, is going to proceed forward most often. For the opposite, which favors the reverse reaction, we want the smallest K we can find. Small K's tell you that that reaction prefers to go backwards. And that happened here in number 9. Hopefully that helped understand equilibrium constants, how to set up their reaction, and then also how to plug it into your calculator. Something I get from my students is, can we do this a different way? Can I distribute? Can I blah, blah? Yes. The answer is yes. Right. Math is a language, and you can say the same thing in multiple ways, just like you can with English, French, German, whatever. The thing I will tell you, though, is that the way that I have done it works. And if you are someone who's not super strong with math, you don't want to distribute, you don't want to do different things, I promise you that doing it the way I have will provide you with the right answer. But it's up to you. Have a wonderful day, and I'll see you next time.